Welcome to Statistics for Surveys, Session 2 Tables, Optional Segment 6, Part 3, a formula for the cumulative frequencies. In this segment, I'll try to show you how to create and read a formula for cumulative frequencies. It helps if you've actually seen Session 2, Segment 2, where we discussed in general cumulative frequencies, and Session 2, Segment 6, Part 1, how to deal with the summation sign. The way we calculated cumulative frequencies by summing up all the previous frequencies and the frequency of the current category. So if we convert this into text, we get the cumulative frequency for category I equals the sum of all absolute frequencies from the first category until that category I. Let's try to make this text formula appear like a math formula. The first substitution we're going to do is cumulative frequency for category I is going to be replaced by CFI. So in our formula that will become like this. We will then have, of course, the equal sign up here. So also in the formula an equal sign up here. And then the sum of all is going to be replaced by the summation sign, gives us the big weird looking E. Then the absolute frequencies are substituted by capital F, which becomes capital F also here in the formula. And then from the first category, which will be the indication below the summation sign and also below the absolute frequency. I'm using J here because I already used I to indicate which cumulative frequency. So I need to use a different letter up here. So I've chosen J in this case. And then till category I, and that will therefore be actually on top of the summation sign. And there you have it. This whole thing is a fancy looking formula to calculate cumulative frequencies. Now, there was also an alternative method, which we saw in the segment where we discussed the cumulative frequencies in general. Again, we can substitute cumulative frequency of category I by actually CFI. The equal sign, of course, stays the equal sign. And then instead of keep on adding up, we can make use of the fact that that's actually therefore similar to the cumulative frequency of the category prior to I, and simply adding the new frequency. So this one is actually indicated by I minus 1. And then add, which is simply the plus, and then the absolute frequency of category I itself, and that's Fi. So combining all of this can also create this formula, which is the alternative way, and the one usually is slightly faster to calculate the cumulative frequencies. There's one small catch though. For the first category, the I minus 1 will become then 0, and then you will have you will need to accumulate the frequency of the zeros category, which doesn't exist, and therefore that's usually defined as 0. So then you get 0 plus F1, which is therefore then simply the frequency of the first category. Now we saw two formulas to calculate cumulative frequencies, so I thought to simply, for completion's sake, add a small proof that those two formulas are indeed actually the same. If we use the first formula we saw with the summation sign, and we write it out in full, and let's say there are like 10 categories, then you get the absolute frequency of the first plus the second category plus the third, etc., etc. And if there are 10, that goes then till 10 minus 1, so the 9th category plus the 10th. But in general, until the ith category. Now, if instead of I, we would use I minus 1, then the I up here also changes in the formula to I minus 1, and that simply means to add them all up until 1 minus I, so until the 9th. So note that the difference between these two is actually only here the additional plus Fi. So if we replace all of this F1 till the frequency of I minus 1 by this one because that's exactly the same, and then we still add the fi, then we can actually say the cumulative frequency of I, which was this one, is all of this, which was the same as this one, plus that last remaining fi, which was therefore up here. And then this whole formula is now the same as the second formula we saw. And with that we've proven that these two formulas are indeed equivalent.